All right, let's talk about something in Python that's super subtle but can cause huge problems in data science. We're talking about identity operators. And trust me, understanding this is the difference between good, clean data and a total mess. So let's jump right in.
Okay, so tell me if this sounds familiar. You've spent hours, maybe even days, cleaning up a data set. It's perfect. You think, okay, I'll just make a quick copy to mess around with. You change one little thing in that copy and bam, your original, beautiful data is now ruined. It's the worst, right? We've all been there.
Let's actually see this happen. Here on the screen, we've got our original data. Simple enough. Then we just do experimental data equals original data. Seems harmless. We go ahead and change a value in our so-called copy, but wait a minute. When we print the original, it's changed too. What is happening? This isn't a bug, by the way. This is actually how Python is supposed to work, and it's all about how it handles objects. So the secret to cracking this case is something called object identity. Here's the deal. Every single thing you create in Python, a list, a number, anything, gets a unique address in your computer's memory. It's like a house's street address. The important thing to get here is that identity is not about what's inside the house, the value. It's about whether two names point to the very same physical address. And that leads us to the two main ways Python compares stuff. First, you've got the double equals sign, double equals. This one checks for value. It's kind of like asking, do these two houses look the same? You could have two different houses on two different streets, but if they're both blue with 3 bedrooms, double equals will say, yep, they're equal. But then you have the is operator. This is different. This one checks for identity. It asks, are we talking about the exact same house at the exact same address? Okay, let's put this to the test with a quick experiment. Check this out. First, we make a list. We'll call it X. Then we just say Y equals X. Easy. And finally, we create a totally separate new list called Z, but we make sure it has the exact same values as X. So think about it for a second. Based on what we just talked about, what do you think is going to happen when we start comparing these three? All right, drum roll please, and here are the results. So, X is Y. That comes back as true. And that makes sense, right? When we said Y equals X, we didn't make a new thing. We just gave the original list a nickname. They're pointing to the same object. But what about X is Z? That's false. Even though they look identical, Python is like, nope, Z is a whole different object. And just to prove the point, if we check X equals Z, that comes back as true because, yeah, their values are the same. Okay, this right here is the moment where it all clicks. You might be thinking, but why? If X and Z have the exact same stuff in them, how can they not be the same thing? It's a great question. We need to look under the hood. We need some real proof. And here is our smoking gun. Python has this amazing little function called ID, and what it does is it just tells you the unique memory address of an object. So look at this. The ID for X and the ID for Y, they are exactly the same. They are literally two names for one object. But Z? Totally different ID. It might have the same contents, but it lives at a completely different address in memory. Case closed. So who cares, right? Why is this so important? Well, if you're doing any kind of machine learning or data science, this is huge. Think about it. Something like 90% of a project can be just data pre-processing. You're always making subsets, changing features, trying stuff out. If you accidentally mistake a reference for a real copy, you could be silently corrupting your original data. And the worst part? You might not even realize it until hours later when your model is giving you completely garbage results. Okay, so how do we avoid this disaster? How do we handle our data safely? Let's take a look at a super common tool, NumPy. We start with a NumPy array A. Then we do the dangerous thing, B equals A. Remember, B is now just another name for A. That's the danger zone. But look at C. For this one, we use the .copy method. This is the magic wand. It tells Python, hey, I want a brand new, totally independent object that just happens to look like A. And this chart just makes it crystal clear. We ask, A is B? The answer is yes, true, they are the same object. But when we ask, A is C? The answer is a big fat no, false. C is a real, independent copy. It's safe. You can go wild and experiment on C all you want, and your original A will be completely untouched. So if there's one thing you remember from all this, let it be this. The .copy method is your shield. It's your safeguard. Anytime, and I mean anytime you need to change a data set, but you have to protect the original, .copy is what you reach for. It guarantees you're playing in a safe sandbox.
And hey, this isn't just for data arrays. This concept goes way deeper. Think about a trained machine learning model. You might have two variables, model 1 and model 2. How do you know if they're pointing to the same trained model in memory? You use is. This is so useful for debugging those crazy complex pipelines and making sure one of your functions isn't messing with a model it shouldn't be.
So we can be defensive about this. We can actually build safety checks right into our code. Check out this function modify array. The very first thing it does before it changes anything is it runs a little check if ARR is original array. It's basically asking itself, whoa, hold on, am I about to mess with the original data here? And here's the payoff. When we try to call that function with our original array, boom, it throws up a big warning sign. It tells us, hey, you're about to modify the original. But if we give it a copy of the array instead, it's like, all clear, you're safe, see? This is what writing smart, robust code is all about. All right, let's wrap this up with a quick cheat sheet. If you need to know if two variables are the exact same object in memory, use is. If you need to know that they are not the same object, use is not. And if all you care about is what's inside them, if their values are the same, then you use double equals. Just whatever you do, don't mix up double equals and is. So now you know. You have the knowledge to hunt down these subtle bugs, to tell the difference between a simple nickname and a true copy. So the question I want to leave you with is, where is this hidden danger lurking in your code? Go take a look. I bet you'll find something interesting.